If you're analysing and designing civil structures, LUSAS provides tools to check reinforced concrete beams, columns, slabs and walls, steel members, steel concrete composite bridge decks, plus tools for bridge loading, track structure interaction, as well as prestress losses and more. This presentation is to give you a heads up on the code of practice facilities that have been updated or expanded in LUSAS version 19. So, the RC Frame Designer offers ULS and SLS checks, including crack widths, for biaxial bending together with overall tension or compression for reinforced concrete beams or columns or piles, in fact, any shape of cross-section and any reinforcement arrangement. You can view utilisation contours or examine the calculations for any location. You can even view moment and axial force interaction plots, on top of which the reporting is transparent and comprehensive. The RC Frame Designer covers the Eurocode, buildings and bridges, with national annexes for 18 countries explicitly included. You may be able to spot your flag in there, plus Singapore, and from version 19 it's extended to cover AASHTO and these Australian, Canadian and Indian codes. Alongside the RC Frame, the Beam and Column Designer, there is the RC Slab and Wall Designer, which offers ULS checks for plate bending including twisting, using the wood armour approach, or to incorporate in-plane tension or compression, using the Clark-Nielsen method. So you can obtain contours of utilisation, or in this case for the required area of steel, for example. It also carries out SLS checks, including crack widths, based on principal moments and stresses. It covers the same Eurocode parts and national annexes as the RC Frame Designer, and also some now withdrawn British and Singaporean standards. Plus various bridge and building codes listed here for the US, Canada, India, Australia, and from version 19 forwards, the Chinese GB50010 bridge code. Cousin to the RC Frame Designer, the optional Steelwork Designer carries out checks on beams or columns or truss members and offers both contours of utilisation for the critical check like this one or for each check in turn, and detailed, transparent, clause reference calculations. The Eurocode bridge and building parts are covered, along with the Australian and Canadian codes, and for the US, AASHTO. Plus, in version 19, the AISC 360. Also new is the Chinese code GB50017. But there's a focus in the version 19 release on steel and concrete composite bridge decks, including faster and better modelling, and the introduction of design checks to the AASHTO code alongside our existing Eurocode product. But these new facilities are covered in a separate presentation. LUSAS also has a range of tools for post-tension structures, including the calculation of tendon losses. As these haven't changed in version 19, they're not part of this presentation, but you can find out more on our website. Now, traffic loading is of course a large part of the workload for any bridge engineer, which is why, for some decade or more, we have been offering the LUSAS Traffic Load Optimizer to identify the most onerous pattern, according to the codified rules, which is a potentially complex task. Taking the AASHTO code, for example, the width between the curb lines is divided into 12-foot lanes. If the width isn't divisible by 12, there may be a number of notional lanes and a remaining area. And LUSAS will position the lanes automatically. And furthermore, when, as in AASHTO, the vehicles or loads can move transversely within their lane, again, LUSAS will do that automatically, all to give the most onerous effect, according to the code. Likewise, variable axle spacing and relieving axles can be omitted as per the rules. So in this 4-girder deck, if we consider girder 2, and here are the curb lines, then the optimised loading pattern for sagging in span 1, well, we can see the notional loads there are in spans 1 and 3, and the transverse positioning 2, with loads clustering around girder 2. Whereas if we look at girder 4, of course, we get a quite different pattern. Here we have only 2 lanes loaded because multiple presence factors are considered, and the sagging at this location is maximised by using 2 lanes with a higher factor rather than 3 with a lower factor. The comprehensive optimizer offers codes of practice all over the globe. The Eurocode with various national annexes, and worth a mention that the UK has a number of assessment codes that are in use and which are also covered, including the recently issued CS 454. But the world coverage goes on to include Canada and the US, with state manuals there taken into account, Saudi Arabia, China, New Zealand and Australia, again including the assessment code, and new in version 19, the Indian IRC6 code. Alongside our vehicle load optimizer, you'll also find our railway load optimizer. This works to UIC 776 and the Eurocode with a range of national annexes, and it also includes the ARIMA and the UK Network Rail Assessment codes. And staying with the railway theme, our rail track analysis facilities enable a fast assessment of track structure interaction, according to the Eurocode, and the UIC 774-3 has wizards to create models that have all the necessary non-linear functionality, and wizards to obtain all the forces, displacements, accelerations rapidly and conveniently. Improvements in version 19 here now allow the location of bearings inboard of the deck ends, leading to a more accurate representation of the deck and rail system, and also allow the definition of multiple train loading groups, making the consideration of many train configurations much more efficient. For all users, we're always looking at how we can improve the speed of analysis and design functions. So first of all, when solving analyses, you'll notice a new option which allows the selection of the fastest available solver, or the frontal solver, which is slower but reports more errors and warnings, making it a good option if you're encountering difficulties obtaining a solution. This makes the fast solver more accessible to all users. On the design side, the RC frame designer runs about 3 times faster in version 19 as compared to version 18. The beam and shell slice resultants tool runs up to 20 times faster in version 19. Influences were made some 7 times faster in version 18 compared to version 17, and the traffic load optimizer also, one test running over 100 times more rapidly. And further improvements in version 19 are still being benchmarked. We hope you'll find the combination of the trusted analysis tools and the comprehensive design tools which are now available with LUSAS will meet your project needs with the flexibility and transparency that you'd expect from us. LUSAS version 19.